Welcome to Part 4 of the webinar series, reviewing the Energy Code compliance for metal building systems as it relates to the Energy Code provisions. In this part, we'll review the trade-off method, specifically reviewing the Department of Energy CommCheck software. We previously recorded for your use a review of the installation prescriptive compliance method. A broad overview was taken care of in Part 1, and this provides an introduction to the 2015 IECC and ASHRAE Standard 90.1, 2013 common terms and provisions. So more in a broad sense was Part 1. Part 2 honed in specifically on the IECC and how to navigate through the prescriptive measures, whether it's related to the U factor method or the R value method. And then Part 3 focuses in on ASHRAE 90.1. This webinar series will get into the trade-off method. I've broken this down into 3 parts. We'll provide a broad overview of the software. Then we'll get into common software inputs as it relates to metal building roof and wall insulation systems. And then we'll get into some case studies near the end. This portion of the webinar will provide more of a higher level review, focusing in on the input screens, specifically for the building envelope, and a quick overview of the checklists that are provided once the software has done its thing and you successfully demonstrated your building meets the minimum or is above code, whether it's for the IECC or 90.1. And of course, we'll focus in only on metal building application, but for a more detailed review of the software, we recommend you listen to the PNNL webinar. This was pre-recorded, a live session back in 2016, and it provides a detailed review of not only the building envelope inputs, but additionally the lighting and mechanical inputs and outputs. It provides a thorough review of the compliance reports, and ironically, it includes a metal building case study, which we must have helped on a number of years ago, so they've kept revamping it to be more current as the energy codes evolved. This is the opening slide from the Pacific Northwest National Laboratory, PNNL. This is a 2-hour webinar that was recorded live, as I mentioned, and it's put on by Pam Cole and Bob Schultz of the Pacific Northwest National Laboratory. For a direct link to the webinar, the web page address is shown at the bottom of the screen. You can find those webinars on or at energycodes.gov. When you enter in www.energycodes.gov, you come to this homepage, and here you can download the latest CommCheck software. To the right of that is the ResCheck software for the residential application. A very helpful tool here is to select the specific state you're doing your project in, and by doing so it'll provide a wealth of information as it relates to that specific state on what energy code they have adopted and whether or not CommCheck is permitted. And we realize this will change based on municipality or jurisdiction, but this is always a great resource to look at first. Lastly, there is a resource center option to click here on the left-hand side of the page. When you do that, you'll be able to view other information such as a web-based version of CommCheck we're using the software-based, Windows-based version. There's other resources, whether it's for the designer or engineer, for the code official, for policymakers, and for architects. So let's get into the software. I always double check to make sure I have the latest software by clicking on the link off of the main homepage for energycodes.gov, and it'll bring you to this page where the current version as of the recording of this webinar is version 4.0.5.3. Typically, this is updated on this website periodically, especially when there's new national model energy codes available, or if they update a state-specific energy code as it relates to CommCheck. So for this case, when they updated this particular version, it noted or updated the New York Energy Conservation Construction Code. You can also select your state or county, and you can use a CommCheck. So you can use CommCheck to show compliance. There is a map provided that is updated periodically. The white states indicate that CommCheck is not applicable. They may not permit the trade-off approach, or they may have their own software. In the past, Florida was not shaded, so it was a white state, and so was Minnesota, I believe. But recently, they have their own state-specific CommCheck software that can be used, and we'll get into that here shortly. But most of the United States is shaded in blue, so by and large, statewide CommCheck is allowed to be used. The green states may vary by county or jurisdiction. The CommCheck software is technically not referenced or any wordage or provisions that would lead one to believe that they could use a software program like CommCheck within the IECC. However, the CommCheck software does support the past 3 versions of the IECC. ASHRAE 90.1 is a different story. It does lead one down that path to use the trade-off approach. It specifically notes a trade-off approach, and it indicates that the trade-off approach should be based off of Appendix C out of ASHRAE Standard 90.1. In fact, CommCheck the software rules are written around Appendix C. The CommCheck is updated for the past 3 versions of the IECC and 90.1 and includes state-specific applications. Trade-offs can be made within the software for the building envelope only and lighting as well, but they cannot be interchanged. You cannot have efficient lighting to offset some of the building envelope provisions. If you wanted to do that, you need to go the whole building energy code route as allowed in the energy codes. So this would allow you to trade off the whole package deal for the building envelope, lighting, and mechanical. But for the trade-off approach, the simplified approach, each of these in their own silos. And we'll hone in on the building envelope. In the end, once you are completed, it'll provide a compliance certificate that you can submit to the building department. And it includes checklists that are useful for the designer, along with the building inspector. CommCheck is applicable to metal buildings, of course, also for other forms of construction. As it relates to metal buildings, you may not have your traditional metal cladded roof and wall system like in the upper left-hand corner. You may have some brick wainscoting and stucco and maybe steel studded walls, although you may have the metal building primary frames and a traditional metal building roof with purlins or secondary framing members, along with a standing seam roof or a through-fastened roof. Or you may have an all-brick building, such as the church in the upper right-hand corner, or a combination of brick or stone masonry and metal paneled walls, such as the lower right-hand corner. Also, you may notice some of these could be considered semi-heated spaces, such as a left-hand corner for the agricultural building, or it could be a combination of a fully conditioned office space and a semi-heated warehouse space. The software allows you to break apart various portions of the building, and if you use ASHRAE 90.1, you may not be required to increase the levels of insulation for the semi-heated space areas. We reviewed all that in parts 1 through 3 on the space conditioning types and how to navigate energy codes. So let's take a look at the main page of the CommCheck software. There are 5 worksheet tabs, for lack of better words, on the upper left-hand corner of the screen. One is for project, which is shown here with all the information shown on the screen right now. If you click on the envelope tab, the information changes, and of course lighting and mechanical. And there are additional requirements in the requirements tab. For the purpose of this webinar, we'll just focus in on the first 2 tabs. If you're unfamiliar with CommCheck, I'll provide a brief overview in the next few slides on how to understand what needs to be inputted and what is automatically provided for you based on your inputs. So let's break down this page a little bit further. I'm using the version 4053. I selected the 2015 IECC code, so that will always show up on the top of the page depending on which version of the energy code or standard you selected. And I expanded the view of the options in the left-hand corner for the File, Edit, View, Options, Code, and Help. So if you select the code portion, you'll have a drop-down menu to select the past 3 versions of the ASHRAE Standard 90.1 or the IECC, and then you have state-specific or Providence applications into the CommCheck software. And those are updated or added periodically. Let's take a look at the options drop-down menu. The options drop-down menu will change based on the code that has been selected. The older versions of the energy code, not very many options pop up. But for the 2015 IECC, as what's shown here, and ASHRAE Standard 90.1, the 2013 would have other options or different information that would be available in the drop-down menu. But for what I'm showing here is the 2015, and this one is unique. When you clicked on the View drop-down menu, you'll have the glazing requirements. Now this is unique to the IECC 2015 version, where it highlights the maximum area weighted average U factor allowed per the energy code on the right-hand column, the upper portion there. And then it'll fill in automatically as you get into the building envelope tab whether the proposed U factor meets the minimum code requirement. And if not, it'll red flag it in red text. And you can always go back to this drop-down menu to see what needs to be improved upon. The solar heat gain coefficient, SHGC, is shown in the bottom portion of the box shown on the screen, and this will indicate the minimum code compliance for vertical fenestration based on the orientation of the building envelope walls, and as well as the skylight maximum solar heat gain coefficient. Moving on, the other portions of the project tab, which includes your location of your project, and then it will automatically tell you which climate zone you are in. So for Colorado, Denver, Colorado, that would be in climate zone 5B. Compliance options, this will vary based on the version of the energy code used, and this is the 2015 IECC. And these are the options you must select if you're going to provide either a high performance HVAC unit, reduced lighting power, on-site renewable energy, and so on for the project to be designed. Also, the air barrier options. What are you going to select? You're going to do the air barrier permeability, assembly permeability, or air leakage test. This is what we reviewed in the earlier pre-recorded webinars. If you're going with the material route, individual material route, so have an air barrier permeability of a 0.004 cubic feet per minute per square foot, or the assembly route, that would be the 0.40 CFM per square foot. And if you do the whole building air leakage test, that would be the 0.40 CFM per square foot. Lastly, you enter in your project information, and this will all be captured in on the compliance certificate report and the checklist for the building official, and also for the architect or designer to keep for his records. You'd also need to enter in the building envelope area types. If you have just one type, if it's an all, if the whole area is considered an office space, you would just put in your office information, the office area, as far as the square feet or the footprint, and the space conditioning type. For the IECC, it's either non-residential or residential. Of course, we're focusing in on commercial applications, so we selected non-residential. However, it does pop up if you select the ASHRAE energy standard, then you would have the semi-heated space option. So for that case, if you had a warehouse office space condition, or if part of the police station, well, that's not a good example. I would say if the warehouse, replace the words warehouse with the police station building type, and if the warehouse square foot area could be considered semi-heated, so you would select that, and then for the office would be the non-residential. And this will be important when it does the energy code calculations on the building envelope tab. These are the options that are predefined for you to select, and the text there may change based on the version of code being used. When you select one of these, the watts per square foot, if you look in the fourth column, notice the number is 1.0 or 0.9. This is automatically calculated, and this is more for the interior or the exterior lighting areas. So let's review the metal building roof and wall inputs. In the previous part of this webinar series, we provided a broad overview of CommCheck and how to navigate the project information page. This will get into inputting specific information into the building envelope page. When you select the envelope tab, you'll have 7 other options for entering in the roof information, the skylight, exterior wall, window, door, basement, and floor information. For now, we'll run through the roof and wall specifically applying it to a metal building insulated system. By doing so, you click on the Roof tab, the white box left-hand corner of the screen, the roof number 1 in the blue line there, and then you click the assembly. You can either click metal building standing seam, metal building screw down, or the other U Factor option, and then you select the metal building roof. So let's first select the metal building standing seam, and then you have 5 options which correlate to the terminology that is used in the energy code. And if you recall from the earlier webinars, the IECC U factor and R value tables points to ASHRAE standard 90.1 for the insulation descriptions. Regardless of the roof or wall type, so for our metal building roof type, for a standing seam roof, you have these 5 options in the Appendix A in Table A 2.3.3, I believe. So single layer insulation with thermal blocks, double insulation layer with thermal blocks, filled cavity with thermal blocks, a liner system with thermal blocks, and a liner system without thermal blocks. So let's get into the drawings that I shared earlier in parts 2 and parts 3 of the webinars. And let's run through some of these. So for the metal building screw down roof, you should be familiar with the single layer system. This is a through fastened roof panel as shown on the drawing in the left hand corner. You would select one of these 2 options. So for this particular one, it doesn't show a thermal block between the purlin and the roof, which is commonly not used with a through fastened roof panel system. And you would enter in the gross area of the roof. Right now there's a 0 red font, shaded 0. So you enter in the gross area. To the right, you enter in the cavity insulation of the R value. So for this particular, the software will acknowledge anything equal to or less than an R19. If you have continuous insulation, such as rigid board for one of the examples, you will enter that into the last column that's shaded blue on the right-hand side of the screen. Or commonly this would be left blank if you just are using fiberglass system. You have to remember the difference between continuous insulation and cavity insulation. Continuous insulation is the consistent R value across all framing members, whether it's installed on the interior or the exterior. For the fiberglass, obviously it would be compressed at the purlin for the roof example, and that R value would not be consistent between what is shown between the purlins, where the insulation should be allowed to fully expand to its effective R value. So you would need to enter in the fiberglass into the cavity insulation R value cell. You can always use the other method. The U factor is calculated based on the reference 90.1 standard information. So if the R19 was entered in, it should automatically come up with a U factor that would align with your expectations. But if you have a tested value that does not match up with what the software provides, you can move away from these drop-down menus and go with the other U factor method. So let's move on to the metal building standing seam roof example. When you do that, you have 5 options, and I'll select the single layer with thermal blocks as shown in the drawing on the left hand side. I would enter in the fiberglass information, so anything R19 or less, and then it would automatically calculate the U factor. So for this case, it would probably enter in a 0.082 for the U factor based off of the 2013 version of ASHRAE standard 90.1 because I selected the 2015 IECC. This version of the IECC would point back to the reference version of 90.1. Older versions of ASHRAE 90.1 may vary in the U factors being presented. These U factors have evolved over the past few versions. Maybe a little bit more conservative, assuming less expansion of the fiberglass between the purlins. However, if you know that the fiberglass has fully expanded to the effective R value between the purlins, and you have tested information that can be included with the certificate report to send to the building official, then again you can go the other U factor route. This next slide shows a double layer system, standing seam roof with thermal blocks. This could be used for a semi-heated space condition. I don't believe this is an option any longer for the fully conditioned spaces in the newer energy codes. However, if you selected one of the older energy code from the drop-down menu, this could very well be an option that you are using, such as in the 09 IECC, allow the double layer sag and bag type of system. So for this case, you would add up the R values of insulation. And if you had like an R13 plus R13, you would simply add up the R values, so it'd be R26. The software does not acknowledge anything over R38. If you put in R38, it would max out at a particular U factor. If you put R40, it would still assume it's still an R38. And if you have continuous insulation, you can also add that, and that would change the U factor. You can always refer back to Table A 2.3.3 out of ASHRAE Standard 90.1 to verify if the U factors align with your expectations. Moving on, this is a metal building standing seam roof again, but with a filled cavity system with thermal blocks. And based on what is available in that table that I keep mentioning, Table A 2.3.3, the filled cavity options max out at an R29 when you add up the insulation levels. So currently, as published in the 2013 version, it only includes an R19 plus R10. However, there is another option that was introduced, which we'll get into a little bit later with one of the examples. In fact, it's an R19 plus R11, and it has a U factor of 0.03. Blanking on the U factor number, but we'll get into that here shortly. And this is a standing seam roof, a liner system with thermal blocks. And there are a few more options in the ASHRAE Standard 90.1, so it maxes out at an R47. So if you have the R25 plus R11, you would just enter in the R36. We realize that you cannot simply add up the R values to equate a U factor, for there is thermal bridging involved, which the code acknowledges when the U factors are calculated based off a hot box test. What this software does, it it automatically references what has been published within 90.1. So it knows that a R25 plus R11 system would have a U factor of 0.031. And this does account for the spacing of the purlins at 5 feet on center, any compression of the fiberglass on the top layer. So the software automatically accounts for this. So this slide will review 3 options, and I just plug them into the software. If you look down at the bottom of the screen, the first shaded row is a metal building standing seam roof, a double layer with thermal blocks, so an R13 plus R13, and the energy code assumes it has an R3 thermal spacer block, and per ASHRAE it has a U factor of 0.075. So I enter in R26. If you look at the lower right hand corner of the screen, third row in to the left, I entered in R26. There is no continuous insulation to add to the system. And remember, the thermal block is not continuous insulation. It's not considered continuous insulation. It is simply the thermal block that goes over the purlin top flange. And it enters into 0.075 automatically. My next example would be row 2 on the bottom of the screen. This will be a liner system. As we reviewed in one of the earlier webinar series, a liner system has a membrane or a vapor retarder that is held up by 1 inch or so steel banding attached to the bottom flange of the purlin, spaced longitudinal and transverse, and then the unfaced fiberglass sits on top of that, and then the top layer is compressed over the purlin with a thermal spacer block. So for my example here, I used an R25 plus R11 liner system, and it comes up with a 0.031, and that shows on row 2 on the bottom of the screen. Lastly, I wanted to show in a filled cavity system which has an exposed bottom of the purlin flange. So the bottom layer of a filled cavity system has a faced vapor retarder included with it. There's still steel banding that's holding up the bottom insulation layer between the purlins, and the top layer is compressed with a thermal spacer block and a standing seam roof. So for this example, I plugged in an R29 and it automatically comes up with a 0.041. So let's get into a continuous insulation layer only option. So if you have a standing seam roof, metal building, you would enter in the R value. It'll max out at R60. Commonly, you would enter in the metal building information, or if it's for traditional construction, you would enter in probably insulation entirely above deck option. So pretty straightforward. No need to enter in the cavity insulation R value. So now let's get into the other U factor option, which is the most commonly used part of CommCheck for a metal building. Reason being, there are many resources out there besides ASHRAE Appendix A tables. And if you have published U factors from another recognized source, you would enter this in, metal building roof. Simply enter in your gross area and manually input the U factor information into the blue cell on the right hand portion of the screen. This would be assumed consistent throughout. If not, you would need to break things up within the software. So if you have part of the roof that is a standing seam roof, and for some unknown reason another part is a through fasten roof, or is not a metal building roof application, but it could be insulation entirely above deck, or it could be a steel joist attic roof system with asphalt shingled roof. Those would be put on separate line items within the software and different square footage entered in. Recognized resources, as reviewed earlier, would be from 90.1, or simply use the prescriptive R values and the published U factors out of the IECC tables. NEMA has published values. That's the North American Insulation Manufacturers Association. Product suppliers has their own test data based off of hotbox tests, finite element modeling, and you may even venture into the calculation methods that are being developed or has been developed within 90.1. These are included in the appendix in the 90.1 2013 edition and expanded a little bit further in the published 2016 edition. We believe it is permitted to use the latest published version of 90.1, even if you're using an older version of the code. For this is a recognized source, and there may be new information that has become available that you may want to reference. So just make sure you have this available. Make a hard copy and submit it with your certificate to the building department. So let's take a look at other information that would be useful to you. A lot of information is shown on this slide. I'll see if I can break it down. So the top row, we'll call this row 1 or roof 1. We have a metal building standing seam roof. We'll use a filled cavity with thermal block as our option, and we'll assume it has a total R value of an R29. So if you look, this information is actually from the 2016 standard of 90.1. If you recall, the format changed, the color coding changed, but still basically the same information. And so it automatically plugs in the 0.041 U factor in the roof 1 row, far right hand column, as the 0.041 U factor. So let's get into R19 plus R11, and that has a 0.037 per the published version of the 2016 standard. So I enter in R30, R19 plus R11. However, it comes up 0.041 because the current software maxes out at an R29. Because this R11 plus R19 filled cavity system was not in the referenced version of 90.1, particularly the 2013 version. So, what do? You go with the other metal building roof option. So see row 3, roof 3, other metal building roof. You would just simply enter in the 0.037 since you want to reference what has been published and what is being supplied by the material supplier. That's how you would get around that, and that's what the software provides. It knows there's other systems out there than the predefined options in the drop-down menu. I did not mention the pop-up note down below. The software provides a lot of pop-up or red flags. And this one highlights it just maxes out from R0, maxes out at an R29. If you read through the text, you get to the end, and it says, as an alternative, consider specifying the assembly as an other, in quotation marks, quote marks, assembly type. So this is definitely permitted. So let's transition into the metal building wall. Specifically, all the insulation options that we have reviewed in the earlier webinar parts and what has been provided or summarized in the second edition of the Energy Design Guide for Metal Building Systems. So you would select metal building wall, and for any of these three drawings down below, you would select the single layer. Mineral fiber is a term that CommCheck uses in the drop-down menu. So you have a single layer or a double layer option. So for the single layer option, then you would enter in either the fiberglass only information and ignore the continuous insulation R value, or it could be a combination of the two as shown in the two drawings on the right hand side of the screen. And remember, the continuous insulation can be installed in the interior or the exterior. There are many forms of continuous insulation out there. I just happen to show one option, which would be the rigid foam board. Other options could be spray foam, could be insulated metal panels. I can't think of any other options, but if you have another option where the R value remains consistent over the framing members or in and around the framing members, as long as it has a consistent R value to avoid thermal bridging, you could use that. If it's fiberglass, obviously it will be compressed in a metal building application. Or even if it's uncompressed, when I'll show you some cavity-filled fiberglass systems, it accounts for the spacing of the girts and any thermal bridging going along through the metal frame member. So the fiberglass does not continue across, it is interrupted by the framing member. Thus, it cannot be considered continuous insulation. Moving on, metal building wall, double layer mineral fiber. And these is a double layer compressed over the girt. And it maxes out at R19 for the fiberglass. So based on the previous tables, you will note in the past two versions of 90.1, this double layer over the girt is not published any longer. However, it still pops up in the software. It is an option in the older energy codes. If you recall, we reviewed a double layer system based on a Addendum CP, Charlie Paul Addendum CP, that has been incorporated into the 2016 standard. And that's not the same as what's shown here. Just showing here what the current software comes up with. So chances are you'll only select this if you are renovating an existing building that has this particular option. And of course, continuous insulation could be installed on the interior, probably not on the exterior because that's a lot of insulation to sandwich between the girt and the metal panel. And I've already reviewed this, that the double layer is not typically constructed, and this is not the same as what has been approved through the ASHRAE process via Addendum CP. So this is what was approved with the Addendum CP. This is a single layer system. This is not the same as a single layer system over the girt. Notice what is shown here. It does include a little break strip tape between the girt and the wall panel. There is no insulation, fiberglass insulation compressed between the girt and the outside flange of the girt. And the fiberglass could be faced or unfaced, and the membrane or facing would be installed on the interior. This is the double layer system we talked about in one of the earlier pre-recorded webinars. So one part is fiberglass is compressed over the girt, exterior of the girt, and the fiberglass second layer on the inside. This has been incorporated into the 2016 version of the standard. So for the bottom portion of the table was added. Previously, you would just have the continuous and single compressed layer of insulation. So this is not an option that comes up with the current version of the software, version 4.0.5.3. It may come up, or it ought to come up in the next updated version of the software to bring it in line with the 2016 option of 90.1. So if you're listening to this webinar and you've updated it to that new version of the software, then hopefully this will come up. You can just simply enter in the cavity R value for the single layer in cavity or double layer, and the appropriate U factor should automatically be calculated and inserted. So for now, in the left hand side of the screen, you would select the other U factor option, select metal building wall, enter in the U factor for the version or the application, I should say, of the insulation, single or double layer, noting that it has the correct thermal spacer block. And if you already use this, just simply enter in the U factor, then you're done. Submit your paperwork and copy of the standard or the Addendum CP, or the insulation supplier could help you out with this as well. Thank you for listening in to this webinar or other webinars in the series. If you ever need to contact us for any project questions or code questions, feel free to contact us. You can find our contact information on our website at mbma.com, or use the Contact Us form, and we'll respond back to you in a timely manner and give you a call to help you out with any questions you might have.